Hi everyone, and welcome to math video number 17. Today we're going to be talking about probability. So SOL 4.13 says the student will predict the likelihood of an outcome of a simple event and represent the probability as a number between 0 and 1. So first, let's talk about what probability is. It's simply the chance of an event occurring. So let's look at our first example. So if you roll this number cube and has 6 sides, what's the chance that it will land on a 4? When you ask a question like that, you are trying to find the probability of it landing on 4. Another example is if you have a spinner and you spin it one time and you're wondering what is the chance that it will land on yellow. And again, you're finding the probability of it landing on yellow. So let's take a look at these individually. So here we go. You roll one number cube with 6 sides. What's the chance that it will land on 4? Well, the way to write that as a number, a probability number, is on top you want the number of favorable outcomes. And that's just a fancy way of saying what they're asking for. So what they're asking for is what's the chance of it landing on 4. So landing on 4 is the favorable outcome. Okay, so how many 4s are on a number cube or on a die? There's only one, right? So we're going to write 1 on top because that's the number of favorable outcomes. And then on the bottom, we have to write down the total number of possible outcomes. So we know that this number cube has 6 numbers on it. So there's 6 possible outcomes. So our probability that it would land on 4 is 1 out of 6. And it's written like a fraction, but that's how you would read it. You would say there's 1 out of 6 chances, or there's a 1/6 chance that it would land on a 4. Now let's look at our other example down here. Here we have a spinner. So first let's figure out the number of favorable outcomes. They want to know what's the chance that it would land on yellow. Well, there's only one yellow section in this spinner, and they're all equally divided. So we'll say there's a 1 for the favorable outcome. If there were 2 yellow sections, we would say 2, but there's only one yellow section, so we'll say 1. And what's the total number of possible outcomes? Well, there's 4 different colors. So this probability would be written like this. There's 1 in 4 chance of landing on yellow, or there's a 1/4 chance of landing on yellow. Okay, so let's take a look at this, because if you notice, every probability number is going to be in between the number of 0 and 1, always. Okay, so for this number line, I have separated, since I had 6 possible outcomes for a number cube, I separated this little section between 0 and 1 into 6 sections. And then I can plot this on a number line by just going ahead and counting one of the 6 spaces. So it's 1/6, and that would be 1/6. This right here would be, there's no chance, 0 out of 6 chances. This would be 1 out of 6, 2 out of 6, 3 out of 6, 4 out of 6, 5 out of 6. And over here, that would be the same as 6 out of 6. And we know that if the numerator and denominator are both the same number, then it equals 1. Okay, so now let's look at our second example that we had. This time I split a number line from 0 to 1 into 4 sections because there is only 4 possible outcomes. And our fraction was 1 out of 4. We had 1 out of 4 chance of landing on yellow, and I could easily plot that again right here, because that would be where the 1/4 would be. This would be 0 out of 4 chances. This is 1 out of 4, 2 out of 4, 3 out of 4, and then 1 would equal 4 out of 4. Okay? All right. So now, if my question wasn't what's the likelihood or what's the probability that I would land on a 4, what if I said, what's the probability that I would land on an even number? That's different, isn't it? So what is the probability of landing on an even number? So we have a 2, a 4, or a 6. There's 3 of those, right? So it could either land on a 1, a 2, a 3, a 4, a 5, or a 6. But these are even. So the number of favorable outcomes is actually 3, because it could be a 2, a 4, or a 6 and still be this favorable outcome of being an even number. So I would have 3 for the favorable outcome, and the total number of possible outcomes is the same. There's still only 6 numbers on the dice. So 3 out of 6, or if you simplified that, that would be 1/2. So this would be like 0 out of 6, 1 out of 6, 2 out of 6, 3 out of 6, or 1/2, 4 out of 6, 5 out of 6, or 1 is the same as 6 out of 6. So the way that you would put that on a number line is just to land it right where it should be. 3 out of 6 are right in the middle. So it's the probability would be 1 in 2 chances, or 3 out of 6 chances of getting an even number. Now, we have these fancy words. We actually use a lot of these in everyday life. Sometimes we use them incorrectly, but for the sake of probability, there's a very clear way and a clear time when you should use these words. Okay, so if there's no chance that this would happen, an event, whatever you're talking about, if there's no chance, then you would use the word impossible. Okay, so that's like me saying, what's the probability of landing on a 7? Well, there's no 7 on this number cube, so the favorable outcome is 0 because there's no 7s, so it would be 0 out of 6, so it's impossible. So that's when I would use that word. What if I said, what's the possibility or what's the probability of landing on the numbers 1, 2, 3, 4, 5, or 6? Well, that's all the numbers, isn't it? So here's our numbers. What's the probability of landing on a 1, a 2, a 3, a 4, a 5, or a 6? Well, that's everything. That's 6, and then there's 6 total spots. So that would be right here. So then I would use the word certain. I am certain that I would land on a 1, 2, 3, 4, 5, or 6. Okay, and then our previous example of it being an even number, remember that was right in the middle. If it was an even number or an odd number, that's when you would use the phrase, it's equally likely that it would be an even number or an odd number. Okay, so you have these 3 main words that we use. And then in between, you see these other words. So we know if there's no chance, it's impossible. If it's absolutely certain, that means there's no way it can't be. If it's half and half, it's equally likely. So if it's less than half, then you're going to use this word, unlikely. If it's more than half, then you're going to use this word, likely. Okay, so those are the phrases that you're going to use when you're talking about probability. And I'm going to show you lots of examples. So let's take this spinner for our example. Remember this. This is our little equation. The number of favorable outcomes goes on top, and the total number of possible outcomes goes on the bottom. Okay, and then if it's a 0, we're going to use the word impossible. If it's a 1, it's going to be certain. If it's half, it's going to be equally likely. If it's more than half, but not all the way to certain, we're going to use the word likely. And if it's less than half, but not impossible, we're going to use unlikely. Okay, so let's look at this first one. What's the probability that the spinner will land on green or yellow? Okay, so green or yellow. There's 2 favorable outcomes, and there's 4 total possible outcomes because it could be either red, blue, yellow, or green. So the probability is 2 out of 4. If you simplify that, that's 1/2. Then look here. It's equally likely. The probability that I would land on a green or yellow is going to be equally likely. So I'm going to draw a line to that. Okay, let's look at the next one. What's the probability the spinner will land on a red, blue, green, or yellow? A red, a blue, a green, or a yellow. That's 4 favorable outcomes. And there's 4 total possible outcomes, right? That equals 1. So, looky here, we can use the word certain. Okay, so I'm going to draw a line now. Oops. I'm going to draw a line to certain. Okay. Let's look at the next one. What's the probability that the spinner will land on yellow, red, or green? So yellow, red, or green. There's 3 favorable outcomes. And there's 4 total possible outcomes. So 3/4. Now that is bigger than 1/2, but it's not 1, so we're going to use this word, likely. So the probability that the likelihood that the spinner would land on yellow, red, or green is very likely. Okay, so we're going to draw a line to that word. Okay, let's look at our next example. What's the likelihood that the spinner would land on red? Okay, we got 1 spot that's red. So 1 favorable outcome and 4 total colors. So the probability is 1/4. So the likelihood, 1/4 is less than 1/2, but it's more than 0. So we're going to use this phrase, unlikely. So it's unlikely that it would land on red, but it's not impossible because there is a red section. Oops. Okay. There we go. All right, so now the last example. What if I said this? What's the probability of the spinner landing on purple? Well, there's no purple square, is there? Section. There's no purple section, and there's 4 total possible sections, so that's 0. And that's impossible, obviously. Okay. All right, so then I would say it's impossible that the spinner would land on purple. Okay, so those are the important words that 4th graders should be able to know how to use correctly. These 5 terms when talking about the likelihood of an event. Okay? Let's take a look at these. Some of these questions I'm going to show you are from Study Island, and some are from IXL. So those are 2 really good places to practice this. So here's a picture. We're pretending that this is like a little box of fruit. And these are pears and these are peaches. Okay, 1 piece of fruit is randomly selected from the bin above. What are the chances that it is a pear? Remember that word, what are the chances? That's the same thing as what's the probability. What are the chances that it's a pear? Okay, so don't forget our little problem here. What we want first in our equation is the total number of favorable outcomes and then the total number of possible outcomes. Okay, so they want to know what's the chances that it's going to be a pear. Okay, so that's the favorable outcome. So let's see how many pears there are. We have 1, 2, 3, 4. 4 favorable outcomes. And then how many altogether? 4, 5, 6, 7. 7. So I could find that over here and I would be able to choose B. Now notice how I drew on the fruit as I was counting. Could you do that without drawing? Possibly. Is it possible to make a mistake if you don't? Yeah. So I would recommend marking it as you count, especially if they give you a lot to count. Okay? Let's look at this example. This is from Study Island. It says Samantha is rolling a 6-sided die. Which of the following number lines represent the probability of Samantha rolling a 2 on a 6-sided die? Well, we know from our previous example from our number cube with 6 sides that there was only 1 4, and so we also know that there's only 1 2. So the number of favorable outcomes would be 1, because there's 1 2, and then there's 6 total, because it says it's a 6-sided die. So there's 6 total possible outcomes. And so then now you need to look over here at these number lines and see which one is represented like that. And you can see it here. So then you would choose Y. Okay, let's take a look at this example now. This is from IXL. If you select a marble without looking, how likely is it that you will pick a purple one? These are your choices. How likely is it? It's impossible, right? That's when you use that word, when there isn't any. That's the only time that you can use the word impossible. Okay, so if I were to say, how likely is it that I would pick a red marble? Well, there's 1 out of 4. So that means it's unlikely, but it's not impossible because there is 1. It's just unlikely that you would choose that one. Okay? If you select a marble without looking, which color are you less likely to pick? Well, we have 2 blues and we have 2 browns. That's even. So that means I'm equally likely to pick either a blue or a brown. So I would say neither. Blue and brown are equally likely. if you select the marble without looking, which color are you more likely to pick? Well, let's see. We have 1, 2, 3, 4, 5 blue marbles and 1, 2, 3 purple. So I'm more likely to pick a blue one. Okay. If you select a marble without looking, which color are you less likely to pick? Well, there's 3 purples and only 2 whites, so I would say I'm less likely to pick a white. Okay, so now in our little equation here, where we have the number of favorable outcomes over the total number of possible outcomes, notice this word, possible outcomes. A lot of our students this year were struggling with this lesson in their online school, finding the total possible outcomes. So we're going to spend a little time now going over how to do that. So let's figure out how many possible outcomes there are if you flip one coin. What's the possible outcomes? Think about that. You just have either a head or a tail. So you have 2 possible outcomes, right? A head or a tail. Okay, that's easy enough. Well, what happens if you flip that coin twice? How many possible outcomes are there? Here's our first event. You have these 2 options. It could land on a head, and it could land on a tail. Now, if it landed on its head, and then we flipped it again, I still have the same outcomes. It could land on a head the second time, or it could land on a tail the second time. And then the same is true down below. If I landed on a tail first, the second time it could land on a head, or the second time it could land on a tail. So these are the possible outcomes this time. It could be a head, then a head. It could be head, then a tail. It could be tail, then a head, or a tail, then a tail. So there's 4 possible outcomes that could take place. Okay? Now, what if we added an extra event? So the first event is to flip a coin, and then you flip it twice, because it says how many possible outcomes are there if you flip a coin twice, and roll a 6-sided number cube. Okay, so we flipped our coin, it's either heads or tails. Then we flip it again, and it's either going to be heads or tails. And then we roll a number cube, and it's either going to land on a 1, a 2, a 3, a 4, a 5, or a 6. So you can see how the total number of possible outcomes are growing fast. So if I were to write all of this out, it would look like this. And the total number of possible outcomes would be 24. Okay, if you look at that, that's very time-consuming and tedious to write that out. But you're going to have to know how to do that in upper grades. So your first possible outcome would be that you would flip a head, then a head, and roll a 1. Or you could flip a head, roll a 2. A head, roll a 3, and so on. So if you could solve this problem by doing this exact thing and get the correct answer, this takes a lot of time, doesn't it? I'm going to show you a quick shortcut. Okay, so this is event number 1. I am flipping a coin. There's 2 possible outcomes, right? It's either going to be a head or a tail. Here is my second event, is flipping a coin. And again, it's either going to be a head or a tail. So there's 2 possible outcomes. And my third event is rolling a number cube. And there's 6 sides to that number cube, so there's 6 possible outcomes. So if I wanted to skip all of this, all I would have to do is come up here and multiply these numbers. 2 times 2 is 4. 4 times 6 is 24. And I am finished. That's quick, isn't it? You could do that with any kind of problem. So let's take a look at a different example. What if, what are the total, okay, no, I think I worded that different. How many total possible outcomes are there if you, let's say, spin a spinner with 4 colors, flip a coin, and roll a number cube with 6 sides. Okay, so event number 1 is right here. We're going to spin a spinner with 4 colors. That's event number 1. And there's 4 possible outcomes. We don't know what colors those are, but it's okay. Event number 2 is flipping a coin. It's either going to be heads or tails. So there's 2 possible outcomes for that one. And then we're going to roll a number cube with 6 sides. So there's 6 possible outcomes. So the way that you solve that, you could go through all of this and draw a picture of it. And you might want to do that at the beginning, so you kind of get a picture and a grasp of what's happening. But once you can picture it in your head, then you can skip to this step where all you have to do is take these numbers and multiply them. So 4 times 2 is 8, and then 8 times 6 is 48. So there will be 48 total possible outcomes just by multiplying the number of outcomes from each event. All right, so that's an important skill to be able to have, to be able to solve probability questions, because you have to know how many possible outcomes are there total.
All right, friends, it's time to show what you know. Go ahead and take a close look at this question. Todd has the following folders in his backpack: 2 blue, 2 red, 2 yellow, 2 purple. The folders are all the same size and shape. Todd reaches into his backpack and selects one folder without looking. What is the likelihood the folder will be green? Would it be certain? Likely but not certain? Unlikely but not impossible? Or impossible? Jeremy rolls a fair number cube labeled 1 through 6. Which red point on the number line below represents the probability that he will roll a 2 on the first roll? Would it be A, B, C, or D? Where is a good place on the number line for that probability that he will roll a 2 on the first roll? Okay, here's another one, friends. It says Lori has a coin with one side heads and one side tails. Which letter on this number line best represents the probability that this coin, flipped one time, will land with tails facing up? Would it be A, B, C, or D? Which place on this number line best represents the probability that when you flip this coin one time, it will land with tails facing up? Okay, last question. It says Mandy is making a spinner game. She wants the arrow on the spinner to have an equally likely chance of landing on each of 4 spaces. Each space will have a different shape on it. Which appears to be the spinner Mandy should make? A, B, C, or D? All right, friends, we've come to the end of math video number 17. Don't close the video until you click on that smiley face and let me know what you think of probability. Is that challenging for you? Is it easy? I'd love to know your thoughts. You have 1 Study Island lesson to complete by Friday, and if you feel you need more practice, go ahead and go to IXL.com. All right, remember friends, what you do every day matters more than what you do every once in a while. That's true for math, that's true for reading, that's true for exercise. So keep being consistent and keep practicing. Bye everybody. Have a great day.
Okay, so now it's time for you to show what you know. I have 4 questions.